This is my precision clock, the most precise and most accurate wall clock you can get. Until now. Introducing the Precision Clock Mark IV. It's even more precise. Yes, the time now reads out to the nearest millisecond, and the entire display has been redesigned so that it doesn't flicker, even when filmed at very high frame rates. The old display refreshed at about 330 Hz, which isn't bad if you're talking about a gaming monitor, but for a precision clock we can do better. The new display updates at up to 100,000 Hz, and it's adjustable, just in case. The display brightness still dims automatically, but it doesn't rely on PWM. The brightness circuit is analog to maximise the duty cycle. Of course, this extra digit means the clock is now even wider. Already I had people complaining that the clock was too wide, that we should have the time and date on separate rows. But if we do that, we lose the aesthetic of it being an ISO timestamp. Well, the only way to please everyone was to give it an articulated joint so that it could transform. There's a Hall sensor, so the top half rotates what it displays automatically. This substantially complicates the design of the clock, but we've not even got to the good bit yet. On the back of the clock, we have a GPS module, which gives us a very accurate time pulse. We have two microcontrollers, one of which has an 80 MHz ARM Cortex M4 with FPU, and we also have 16 MB of flash memory, all of which might seem a bit much for a clock. But on board that flash memory, we have a simplified world atlas extracted from OpenStreetMap data that gives the country and time zone borders. We also have a compressed, processed version of the Olson time zone database, and that ARM Cortex M4 snorts all of this in, looks at the GPS position, and performs a horrendous point and polygon algorithm in order to figure out which country we're in, what the time zone offset is, what the daylight saving rules are, and finally figures out what the time is. That's right, you can take this clock anywhere and it will tell you what the local time is. You can carry it across a time zone border and it will update. You could take it out to sea or the middle of the desert and it will tell you what the local time is according to the time zone database. It will even work on Lord Howe Island, where during daylight saving they put their clocks forward by half an hour. No need for Wi-Fi or networking, no need for a SIM card or cellular modem, no long-wave antenna, just GPS. This zone detection is based on the work of Evan Siroky, who created the time zone boundary builder, and Berthold van den Berg, who created a reference implementation on how to use it. What I've done here is port it to a bare metal embedded system along with the time zone database so that it functions as a completely self-contained unit. Eventually, the time zone data will go out of date. Time zone rules and even country borders are not set in stone, but for when that happens, we have a USB port, which enumerates as a mass storage device. Updating the database is as simple as copying the files across. Since it was easy enough to add, this clock also supports multiple display modes. Along with ISO date, we have ISO ordinal, that's day of year, ISO week, the weird financial one, decimal Unix timestamp, which pleasingly fits into 10 digits, Julian date, modified Julian date. We even implemented a high-precision countdown mode. But if that's not enough, adding new display modes is easy, because firmware updates are as simple as drag and drop. No drivers needed. But perhaps my favourite feature of this clock is that the precision is dynamic. If it loses GPS signal, or if it's been turned off for a while and only has the coin cell-powered quartz crystal to go by, then the last few digits of the display start to disappear. In other words, the precision of the display implies the tolerance of the current time. They say that a man with one clock knows what time it is, but a man with two clocks is never sure. Unless, of course, those clocks display a tolerance. If I look at the clock and the milliseconds is ticking, I know that the time is accurate to within a millisecond. If the last digit disappears, then I know that the time it displays is only accurate to within 10 milliseconds. And if the last two digits disappear, Well, at that point, it's just not worth bothering with, but at least we know that the time it displays is not accurate. It never implies an accuracy that it doesn't have. And now that I've experienced this, I don't understand why it's not a feature of all clocks. In a previous video, I compared my precision clock against a commercially made radio-controlled clock, which I found to be a lot less accurate than I'd expected, even accounting for the fact that it doesn't correct for the speed of light delay, which GPS does. The truth is, this radio-controlled clock only attempts to synchronize once per day, and between syncs, it will drift as much as any quartz clock, maybe half a second or more. Those tests were done using a consumer-grade 1000 frames per second camera, and I did use the same camera for the development of the Mark IV, even though it's not quite fast enough to be helpful. Interestingly, the viewfinder decimates the frame rate, so when we preview the clock, the last digit appears static. Yet it still has a rolling shutter effect, so when we tilt the frame up and down, the last digit changes. But this doesn't prove that the clock works, so I made some inquiries and befriended a local studio called Pirate, who very kindly gave me some time on a Phantom Flex 4K. We first filmed it at 3000 frames per second. The important thing to note in this footage is the PPS LED here. The rising edge of the PPS signal signifies the start of the UTC second with exceptional accuracy, so the goal is to have our display roll over at exactly the same moment that the LED lights up. Perfect. It took us a while to figure out how to do this, but if you drop the resolution, it's possible to reach much higher frame rates with this camera. Here's footage of the clock face at 14,000 frames per second. You can see that unlike the digits, the colons are driven using PWM. Finally, by squeezing the frame down to just 16 pixels high, we were able to film the clock at 25,000 frames per second. This is the development clock showing debug data, but it's clear that the display is rock solid. If you want to know more about the technical details of how this clock works, I've written a ridiculous number of words on my website, and I might also do a follow-up video with more of the tech details for those who really want it. I sank so much time into the development of this clock, you have no idea. The plan was to sell it as a kit, but when the pandemic-induced chip shortage hit, most of the parts became impossible to get. I didn't have the heart to redesign the clock, so I waited it out, and when the parts finally did come back into stock, I bought a whole load of them, without really thinking about it. It was for this reason that I borrowed that pick-and-place machine I may have mentioned a few times. I tried to assemble 100 precision clock PCBs. It was a learning experience, and I may have gotten slightly distracted once or twice along the way. But I do now have some number of populated circuit boards, along with the rest of the bits needed to build the kit. So if you'd like to own a Precision Clock Mark IV, then head over to my shop. I did unfortunately have to set the price point quite a bit higher than I was hoping, but it's an accurate reflection of how much work I've invested into the project. The software for the clock is open source, and I'll publish the PCB files soon as well. I originally wanted to end this video with an artistic assembly montage of the kit, but I don't think I could ever outdo the glorious musical sequence I made for the previous precision clock. I might do something like that later, if the enthusiasm strikes. For now, I'll just say what a relief it is to finally publish this. This project has hung over me for so long, but now, at last, I'm finally free to start working on the Precision Clock Mark V.